Day 11 of 60. We have Prometheus for metrics and Grafana for dashboards. Now we need centralized logging. The ELK stack is the traditional answer, but Loki offers something different. Elasticsearch indexes every word in every log line. Powerful, but expensive. At 500 gigs of logs per day, your Elasticsearch cluster can cost more than the applications it monitors. Loki takes the opposite approach. It indexes only label metadata. The actual log content gets compressed and stored in object storage like S3. Let me walk through Loki's distributed architecture. 4 core components. The distributor receives incoming log entries from agents. It hashes each entry by its label set and routes it to the correct ingester using a consistent hash ring. Ingesters hold recent log data in memory, batching entries into compressed chunks. Periodically they flush those chunks to object storage. The querier handles your LogQL queries. It checks ingesters for recent data and object storage for anything older. Finally, the compactor runs in the background. It merges small index files into larger ones and enforces retention by deleting chunks past their TTL. In production you run multiple replicas of each component. Typically 3 ingesters with replication factor 3, 2 distributors behind a load balancer, and 2 queriers. Now we need to get logs into Loki. That is Promtail's job. Promtail runs as a daemon set on every Kubernetes node. It discovers pods through the Kubernetes API and automatically attaches metadata labels, namespace, app name, container name. The key configuration is pipeline stages. These parse structured data from raw log lines. For an Nginx container, you might use a regex stage to extract the HTTP method, path, and status code. For a JSON logging service, use the JSON stage. Here is the critical rule: only promote low cardinality fields to labels. HTTP status codes have maybe 5 unique values. That is fine as a label. IP addresses have millions of unique values. If you promote that to a label, you create millions of streams, and each stream holds a chunk in ingester memory. I have seen a single misconfigured Promtail take down a Loki cluster by creating 2 million streams in an hour. LogQL is the query language. It has 2 parts. Stream selectors pick which streams to read based on labels. Curly braces, label equals value. Filter expressions narrow down within those streams. Pipe equals for substring match, pipe tilde for regex. Let me show you a real investigation flow. A security alert fires for unusual authentication failures. Start with a broad query. Namespace equals production, app equals auth service, filter for authentication failed. Now parse the log lines. Use the JSON stage to extract user ID and source IP. Add a filter, source IP not in your internal CIDR. Now you see only external authentication failures. Wrap that in count_over_time to see the trend. Wrap it in topcan sum by source IP to find the top offenders. The progression from log query to metric query happens naturally in LogQL. You do not need to switch tools. For queries you run repeatedly, create recording rules. The Loki ruler evaluates LogQL metric queries on a schedule and pushes the results to Prometheus via remote write. Define a recording rule that counts authentication failures per app over 5-minute windows. Now that metric lives in Prometheus. You can alert on it with standard alert manager rules. You can graph it in Grafana over weeks and months. You get log-level precision with metric-level query performance. This is the log-to-metric bridge that makes Loki practical for production alerting. Without recording rules, every dashboard panel runs a full LogQL query against stored chunks. With recording rules, Grafana reads a precomputed Prometheus metric. The difference in query latency is orders of magnitude. Label cardinality management. This is the single most important operational concern with Loki. Every unique combination of label values creates a stream. Each stream consumes ingester memory. Set max_streams_per_user in. Limits_config. Monitor stream counts with Loki's built-in metrics. Alert when you approach 80% of the limit. Enforce label policies at the Promtail level. Drop any label with more than a few hundred unique values. If you need to search by a high cardinality field, keep it in the log line and use a LogQL filter expression. Multi-tenancy helps isolate the blast radius. With auth_ enabled true, each tenant has separate rate limits and stream quotas. One team's misconfiguration cannot take down logging for the entire organization. Quick summary. Loki indexes labels, not content. That makes it cheap. Promtail ships logs with automatic Kubernetes discovery. LogQL gives you both log search and metric computation. Recording rules bridge logs to Prometheus. And label cardinality is the thing that will make or break your deployment. Control it through Promtail relabeling, limits_config, and monitoring. Tomorrow on day 12 we build structured alerting pipelines on top of this logging foundation. See you then.